Number 70. A child has a hearing loss of 60 decibels near 5,000 hertz due to noise exposure and normal hearing elsewhere. How much more intense is a 5,000 hertz tone than a 400 hertz tone if they are both barely audible to the child? All right, so basically the barely audible thing on this graph is going to be the zero phone value. So let's first find the value at 5,000 hertz. So here's 5,000. The value here on the graph looks like to be about here to me. And if I were to draw the line on over, it looks like it has about a -4-ish. I don't know, somewhere around there, right? Maybe -5, -4 decibel value. But they do say that he has a hearing loss of 60 decibels. So that means that in order for the child to actually hear this -4 decibel value will have to be amplified to 60 decibels, okay? Excuse me, amplified by 60 decibels, all right? So that means we have to add 60 decibels to this -4 value to find then the actual decibel value, right? So the actual decibel value here is going to be about 56 decibels. Okay, let's keep that in mind. Then at 400, so let's find 400 on the graph. So here it looks like it's just below 10, right? If I were to draw the line over, it's just below 10. So maybe that's about 9. This is 9 decibels. So what they're asking us is how much more intense is this, 56, than 9? Okay, so how do we find that? Well, we can simply take a ratio if we wanted, right? It depends on how we want to look at it. To find a ratio, right, we could simply, if we think about doing it this way, remember the formula for intensity here. Intensity is going to be solved already in terms of decibel. It's going to basically be the decibel value over 10 minus 12, right? So this is all in the exponent. So if I take the higher decibel, well, yeah, that would correlate with the higher decibel, but the higher intensity and divide it now by the lower intensity. That's 10 raised to the decibel value. That's the lower one, right? Divided by 10 minus 12. What's the ratio now, right? So this will be, we can also do a subtraction actually. This will be fine. So this is the higher over the lower, right, will be equal to then 10 raised to the higher value 56 over 10, right, minus 12, divided now by 10 raised to the 9 over 10 minus 12. And now dividing these basically into one another. Actually, why don't we just do the math? I was going to simplify it, but it doesn't really matter, right? I mean, you could just plug it into the calculator. So why don't we just do that? So this is basically going to be 10 raised to the 5.6, right, minus 12. And then that's divided now by 10 raised to the 0.9 minus 12. And what do we get? We get a value here of about 50,000. All right, so that's that's how much more intense it would be about. So there's about 50,118, right? Or about 50,100 times as intense. All right. Your number might be off, though, if you choose to use if you're interpreting the table slightly differently. So it'll be somewhere around there. It'll be in the tens of thousands. Guys, thanks for tuning in. Appreciate it. Please remember to subscribe. We'll see you soon. Bye.